Hi, my name is Kyle Banker, and I work at 10gen. I work on the drivers for Ruby and Python, help out with the language communities. I'm really grateful to be here speaking. John Hornbeck from Engine was originally going to be doing this presentation, and he wasn't able to make it at the last minute, and I found out about 4 or 5 days ago that I would be coming down in his place to present MongoDB to you. So anyway, I'm honored to be here. Obviously, a lot of very intelligent people and exciting people here who are excited about the NoSQL movement. I'm coming from more of an application developer's background. So before I worked at 10gen, I worked at Alexander Interactive, which is an interactive agency in New York City. We built mainly e-commerce websites. So I worked on a Java platform called Open for Business, and we built actually a few top 500 internet retailer websites. Also just a number of kind of social networking types applications for startups in Django and in Ruby. I also built an e-commerce framework in Rails that we used for a lot of clients. And so the thing that initially got me interested in MongoDB were more kind of application development kinds of concerns. Thinking about how I'm going to model my data and the ease of modeling my data. Because what you find, I think, when you're getting into complicated data models in relational databases is that you get this explosion of tables, of normalized tables, that are extremely difficult to map to the mind of an average human being. And I got excited about document databases and MongoDB in particular because I feel like the mind map of the data is a lot cleaner. I can understand my data more easily, I can work with my data more easily, and when I go to the database to get my data, it comes back in a single hit and I have my entire data object there. So that's going to be the perspective I'm coming from, a little bit less in terms of operations. I will talk about the kind of scalability features of MongoDB, and hopefully you'll get a sense of that. But I also want to talk about the kind of perspectives of actual application developers who are using MongoDB to build the many applications that make up the web, and the great many that don't necessarily even need to scale to these great heights that we see with, for example, Guilt Group. So for example, even in the place I worked before when we were working on actionenvelope.com and steinersports.com, which are top 500 e-commerce sites. These are important sites in their niche, only needing like a single basic database MySQL server to run what is still a fairly high revenue, high traffic site. So what's the benefit there for a NoSQL database? Yes, there's a performance aspect, but also, and I'll get to this again, there's the aspect of being able to understand my data and understand its representation in the database much more easily than I could with a relational database. So sorry, that was kind of a long introduction. I'm going to divide this talk up into 2 parts. So the first thing, I'm just going to talk about the features of MongoDB that I think make it unique, that I think make it easy to work with for application developers, introduce some basic terms, and then during the second half, I want to talk about 3 different organizations that have used MongoDB successfully and talk about the experiences of their developers using MongoDB. So for just a few basic terms, documents, BSON, collection, and GridFS. Now, most people here know what a document-oriented database is and know what documents are, but just to review, a document is a JSON-style data structure where I can have keys and values, and I can nest my data, meaning that I can create objects within objects. In other words, I'm able to simplify the kind of relational model that I used to have into a single document. Now, documents inside MongoDB are represented in a form called BSON. BSON is a binary representation of JSON that gives us extra types that we might need. So JSON, we all know, is a fairly simple format. We have things like literally numbers, a number data type, and a string data type, and an array data type. BSON gives us a few extra things, most notably a binary storage format, date storage formats, object ID formats, regular expressions. So the data actually, when we send it to the database, is actually stored in this BSON format, and the database understands BSON. And I'll talk about the advantages of that in just a moment. But just as another side note, we see BSON as kind of a general purpose data language and not something that is specific to MongoDB. So for applications, RPC applications, when we need to send structured data, we find that BSON can be an effective means for that. So just another really basic term is collections. We store our data in groups called collections, and collections are analogous to relational tables. we can support up to 40 indexes on collections. And I'll talk about indexes in more detail in a second. We typically use informal types of namespacing to keep our collections logical. And the important thing to remember is that collections are schema-free. It's a schema-free database, so a collection does not define a particular type of document. Our application code defines what type of documents are going to fit into our collections. And that's going to be important later on when I talk about kind of the primacy of application code with a database like this versus the database code. It's the application that defines our schema, the application that decides what goes into the database. The database is a fast storage mechanism for object-style data. GridFS is another term that you'll see when you start to read about MongoDB. GridFS is basically a convention or specification for storing large binary objects inside the database. So we think that MongoDB is good for not just storing the typical data that you store in a relational database, but also for storing things like videos, music, large images. And basically the idea is this. Every document inside of a MongoDB database has a 4 megabyte limit. So you can store, for example, 4 megabytes of binary data inside that document. And GridFS is a convention implemented by all of the MongoDB drivers for basically creating two types of collections. We create our files collection, which chunks all of the binary data in whatever object we're trying to store into 4 megabyte chunks, and then a metadata document that kind of manages that, so that we can do interesting things, for example, such as range queries, where if we're streaming a binary object to the user, we can actually make that database call a little bit more efficient over a range. Typically, these large binary objects stored in the database are processed through our application code and processed through our drivers. But one of the things that we're working on and that we're also encouraging development of are plugins for the major web servers, so that we can kind of mount those that data as a file system on the web server, so that we can serve it directly through the web server rather than having to go through the application. But this is something that people are using in production, so you have entire sites where people are storing not just their data, but all of their binary images right on the database, all their music right in the database, so that they don't have to deal with the bizarre abstraction of the file system and having to, when it comes to something like a migration, having that huge mismatch between all of our metadata that's stored in our database and then this completely different representation of our data that's stored in the file system. So I'll give an example in a few minutes, but musicnation.com, which stores all kinds of, I guess, amateur music, people who are wanting to make it big in the music industry. They store about 1 terabyte of data, and all of their music and all of their video are stored inside MongoDB itself, in addition to the rest of the application data. So those are a few kind of basic terms that you'll see when you're investigating MongoDB. I want to give just a couple kind of minor technical bits of information. So MongoDB, you communicate to MongoDB over a socket. So that's kind of one difference between us and CouchDB. We're using HTTP protocol. MongoDB defines its own wire protocol. And that wire protocol, typically what's going over that is serialized BSON. So we have drivers that are supported for most of the major languages. And when people are using MongoDB, typically they're using one of those drivers. The drivers do a couple of interesting things. One is they pre-serialize all the data into that BSON format. So typically, like in your language, if you're using Python, if you're using Ruby, you're typically representing your data as some kind of hash or dictionary structure. And that data might be nested in any number of ways. It's all being converted to BSON on the client side. And the other thing that's interesting that's happening on the client side is object ID generation. So for a lot of applications, we're doing a kind of forget and fire type of architecture where we create the object ID on the client end, send it off to the database, and we don't have to wait for a response from the database to continue using our object. So that's kind of one of the optimizations of MongoDB. The other being that the data is literally stored as the BSON object in MongoDB. So when we make a query to MongoDB, comes straight back as BSON out of the memory mapped files that MongoDB uses. So it's very fast. MongoDB features a JavaScript shell for administration. So you have your Mongo process running, you fire up a shell, and it's basically a SpiderMonkey JavaScript interpreter. And all of the kinds of administration that you do and any kind of query you can do is done in JavaScript. I think this is very valuable. So you can look at your data using a programming language that most people are familiar with. And you can store JavaScript functions inside the database, things that you commonly do for maintenance, for example. And that's about all we have in terms of administrative tools. We don't have, for example, a web-based admin. We're working on something like that. But nevertheless, it's because our data is document stored, because you can perform these powerful queries using an actual programming language as the main shell, we think it's easy to get a look at your data and to manipulate your data, even as a developer. So you're not sitting there, for example, joining a bunch of tables together or trying to remember what your document structure or what your schema structure could possibly be. You have these kind of self-contained documents that are easy to think about and easy to work with in a JavaScript shell. So just a couple architecture bits. Replication, we use MongoDB. MongoDB uses replication for failover and for redundancy. We have a master-slave setup. And so certain people who are using MongoDB in production are scaling. If they need to scale reads, for example, they can use a simple master-slave. The slave will pull the master asynchronously and keep basically up to date, and then we can send a lot of our reads to the slaves to optimize for reads. Another kind of interesting architectural idea is the idea of a replica pair. Replica pair is basically two machines, each running a MongoDB process that can be either master or slave. One of them, you're connected to master at all times, and the slave is behaving like a normal slave. But if master ever goes down, the driver knows to connect to the other database. The other database becomes master until the first machine can come back up. And so it's a way to provide some sense of reliability, especially when we talk about our sharding setup. So right now, sharding is in Alpha 2. Nobody is using it in production yet. People are definitely experimenting with it. And I'm going to give you just kind of the basic idea. The idea of sharding in MongoDB is based upon a shard key. So for each of your collections, you define some kind of index, and it can be arbitrarily complex. So it could just be something like, last name. But if you needed to index on an inner document or on multiple documents, you could do that. And the MongoDB process will efficiently distribute out the collection among all the shards in your setup. Each of the shards runs as a replica pair for redundancy, because obviously we wouldn't want one of our shards to go out if a quarter of our data is on it. So we run a replica pair so that we have that master-slave failover. And we can easily add nodes. And the MongoDB process on the left, the config server, will migrate the data in order to rebalance if we need to rebalance data at a later date. Removing nodes is still something that we are working on. But that's basically, also the other thing to mention is that you can have as many MongoDB processes as you want. So if you need to scale for writes, you can connect to multiple MongoDB processes, and that. So just a couple of other features about MongoDB that I think make it easy to work with. And like I talked about document-oriented databases a second ago, and I want to talk about dynamic queries in MongoDB. Querying is very powerful in MongoDB. You have basically the level of query power that you do in a relational database. So here's a sample document. Here's a sample. Now, normally in a relational database, what we would do is, for example, you can see we have a key called tags, and we have NoSQL databases, C++, in our example blog post document here. In a relational database, typically we'd completely denormalize that. We'd pull that entirely out. Same with comments. In a relational database, we'd have a separate comments table. We'd have to do a join if we wanted to find comments on this particular post. But in this case, everything is the same object. Now, we're able to do arbitrary queries, ad hoc queries, on any of the objects here. And I want to give you a couple of examples of that. So here are some examples. Find all the posts whose author is Kyle. The second example is a little bit more interesting, finding all the posts tagged with NoSQL. The interesting thing you'll notice here is that tags, the data structure in tags is an array. And yet we can create an index on that key, on the key tags, and the database understands that that's an array and will index it appropriately. So when we make this call to post.find tags with NoSQL, that's actually an efficient query. We also have a number of operators that allow us to do kind of more complex operations. And this gets back to the idea that MongoDB actually understands the structure of the data internally. So we're able to do queries on dates, for example, just like we would in MySQL. And we can do post.find where the date is less than or equal to now. That doesn't make any sense. But we can do date ranges of arbitrary complexity. The same goes for nested documents. And this is a structure that you're going to find yourself using a lot in MongoDB. And I showed you this just a second ago when I showed you the comments. We have our blog post object. And then inside the blog post object, we have an array of each of the comments on that post. So we're not totally normalized, right? We're denormalized in a sense. But it's better just to think of it as we're representing the object as it actually is. And even though we're representing the object as it actually is inside a document-oriented databases, we're still able to do interesting kinds of queries on those internal documents. And so we have a dot notation. And you can see on the second line right here, I'm doing db.post.find comment.author Fred. And so I'm actually reaching into the inner document and able to do interesting queries across all of my data. And not only that, I can build indexes on inner documents. So you see the very first line, I'm creating an index on comments.author. So that query can still be efficient. Also, this is just another example of doing sorting on the data with our index and bringing out only, for example, that inner structure. So if I just want to pull back just the comments, I don't want the post itself, I can specify that just as I would specify the fields in a SQL query that I want. So again, just to kind of reiterate some of the query options, you can see all of these operators beginning with a $sign at the top, greater than, less than, greater than equal, less than equal, not equal, all, in, not in. All of these are kinds of queries that I can do in the fashion that I showed you just now with the date query that I did. In addition, if I need to do a more complex query that I might not be able to express in that form, it's going to be a little bit less efficient, obviously, but I can use a where clause and insert arbitrary JavaScript inside that where clause to query as I need. A couple other kind of the powerful query mechanisms inside MongoDB: support for counts, grouping, distinct, regex queries. If you have a simple regex query like name starting with B, then that will actually utilize the database's index. So they are still efficient. We have MapReduce, and I'm glad that Justin mentioned the confusion over MapReduce, because I feel like MapReduce means something different every time somebody talks about it. And in MongoDB, MapReduce is basically an advanced form of querying. So if you need to do special kinds of aggregations for yourself that aren't supported natively by the query language, you can write yourself map and reduce functions that can output to a collection of your choice. Upserts are upserts are basically an optimized way of inserting data. A lot of times we have the problem in I guess any database where we have to see if an item exists before we actually insert. So this is basically the equivalent of create or update, an upsert is. I can give it an ID or a unique key, and I can forget about it when I insert into the database, making, again, for kind of a faster operation with the database. Capped collections is another cool feature of MongoDB. It's the idea that I can specify a maximum size of a given collection. So one of the applications that people are using MongoDB for is logging. And it's obviously important to age out log files. So this is an efficient way of inserting. We keep the data in natural insertion order. And when they age out after the time we specify, we have kind of a rolling log that we can use inside the database itself. So people are also using MongoDB for logging in addition to kind of the new kinds of data modeling that I'm excited about. So MongoDB in production. I'm going to give 3 examples of MongoDB in production. Each example uses a different language, so hopefully those of you here who are application developers can identify in some way with the people I talk to. And I talk to people at each of these companies. The first is BusinessInsider.com. Business Insider is a basically Web 2.0 news style site. So it's something like a Huffington for business and for technology. They get a pretty decent amount of traffic. They've been using, well, first of all, they've been using MongoDB for 2 years now. They get 12 million page views a month, 2.2 million uniques a month. So obviously it's not the hugest media site on the internet, but they're doing well and they're using MongoDB 100%. They use the PHP driver, and then the lead developer has also built like a very simple object mapper on top of that driver to make his life a little bit easier. So one of the things when I was talking to Ian, who's the lead developer there, that they like about MongoDB is the simplification in data modeling. So originally, this was basically a blog format style medium, and they were using movable type, and they had dozens and dozens of tables. And they like the fact that now that they're using MongoDB, they can reduce that kind of normalized huge number of tables down to about 10 collections. And many of those 10 collections aren't even for storing what you would consider the core content of the application. So, well, the core content being posts and images and embedded comments and user data. But they also store a lot of settings, so a lot of customized settings. For example, in the layouts are hitting the database every time a page loads. They're doing real-time analytics. I'll talk about that in a second. To be fair, like to be totally accurate, they are using Facebook Connect to store the images for their user data. So not every single thing is inside MongoDB. But I want to talk about analytics really quickly on this site. So this is a news media site, and they have a publishing room, and they have reporters in there who are trying to crank out the latest gossip, basically, in the business world. And they need real-time analytics because they need to see how their users are responding to that information. So what they're able to do is they're able to use MongoDB for those real-time analytics. And what Ian has built out is a kind of heat map that overlays on top of the main pages of the site, and he can see he can see immediately dynamic feedback, what kinds of articles are doing well, which subsections of users are responding to them. All of that because he's able to, every time people are clicking on articles, he's tracking the users, and he's sending it to MongoDB. So he's using MongoDB for a couple of things, right? He's not just using it for the core content of the site. He's also using it for analytics, for kind of knowledge gathering. MongoDB has very fast inserts. Like I spoke about a couple minutes ago, we do use memory mapped files. I don't know if I can comment on the Tokyo Tyrant example we had this morning, but that is one of the ways that we get fast inserts. Another way fast inserts, like I said, we create object IDs on the client, and we're able to throw away and forget about it. Another kind of side note, the application uses Sailthrough, which is a basically click tracking company. And one of the interesting, they use MongoDB actually for tracking clicks, obviously. So the user gets a cookie and they're tracking their clicks. Now the interesting thing about that, and the cool thing about using a document-oriented schema-list database for that, is that no matter what kind of categories I send to that click document, I don't have to think about it. I don't have to think about a special kind of data model, okay? So I don't know exactly what kind of information is going to get sent to my click tracking, and I don't have to know about it, because I have a schema-list database, and it can take care of that. So I can still build out all the aggregations I need on the user data, on the user behavior, click behavior, without thinking about a data model in advance. Just another thing, I mentioned this before, but all the images on the site are managed with the GridFS specification that I told you about. So all the binary data is stored there. They have the metadata alongside their images. One possible, I guess, drawback to doing this is that the database can become very large. That's, I guess, the one complaint that Ian has. But the nice thing about it is that all of your data is in the same place and basically speaking the same language of the same structure like I spoke about before, so that migrations later on, everybody who's an application developer has dealt with that mismatch between storing information, storing data on the file system at the same time as storing metadata inside of a database. And that kind of mismatch can be a real headache when you're moving from one system to another. And so this keeps it all in one place. It is fairly efficient. They're not having any problems with it whatsoever. But like I said, we're encouraging people to build out those plugins for the various web servers so that we can make it even more efficient. Again, simplified schema changes. Anytime somebody has to add a field, as an application developer, you know how much time that we spend migrating our data, creating a migration, making sure that all of the developers on the team get the memo that I've changed the schema. Okay? So one of the things they like about this is they can add a field when they need it. So their code really defines the schema. Okay? And we don't have to worry about satisfying both systems. We don't have to worry about satisfying the database system and our source code. We only have to worry about our source code. Certain data migrations are still necessary. So obviously, if you're going to be restructuring the way you store your data. Yes, there will be data migrations, but the sorts of data migrations that are often annoying and time-consuming over the life of a project are mitigated when you use a document-style database like this one. I just wanted to put this up here because this is a real document from BusinessInsider.com. This is one of their post objects. You can see they store, a lot of this data is fairly flat. Down here, it's kind of interesting. One of the things they've been doing, and this is not necessarily recommended, but one of the things they've been doing is actually full text search with MongoDB. So they've written application code that actually stems and gets all the unique words from individual posts and actually throws it into an array so that they can later on do full text search with that. And it works fairly well with the querying capabilities of MongoDB. Obviously, it's not ideal, and they're working on integrating with a separate real text search engine. But it's interesting to know they have been able to use MongoDB, again, under the load that they have as their search server, in addition to analytics and storing their main content data. Comments are also, they have comments, they have nested comments. So you can have actually, if you have an article that's incredibly popular, and you have dozens and dozens of comments that are nested, you still store that in the same object. So these comments are referencing parent comments, et cetera, but the nice thing is I can go to the database, and with a single hit, without having to worry about any kind of join, I can grab that. So that's efficient, right? So we're not having to go to different parts of the database, joining data together, and then bringing it out. We bring it out in a single hit. So it's efficient for the way we think about our data, and it's efficient for getting data to and from the database. So just a couple notes on the deployment of BusinessInsider.com. They have a single database server, 16 gigabytes. It's usually running at about 15 to 30% load, a little bit less. 3 Apache PHP servers, MongoDB for caching, meaning that he's not implementing any other caching strategy except using MongoDB as his database. The only other time he's using caching is for the front page. The front page happens to do queries on quite a bit of different collections, and so he's using a memcached layer on top of that to make that just a little bit faster. I'm trying to see how I'm doing on time. That should be okay. The second kind of case study I want to talk about pretty quickly here is a web consultancy. They're called they're called Squeegee. They've built basically a lot of Twitter mashups. This is kind of one of their famous award-winning sites, tweetcongress.com, which aggregates all kinds of Twitter messages from all of Congress, right? And so basically, using MongoDB for a couple months now, using the Ruby driver, using Mongo Mapper, which is the preferred way, or one of the preferred ways of modeling your data inside Ruby. Things that Jim at Squeegee likes about MongoDB, again, that version-controlled schema, the idea that your code is defining your schema again, so it's very easy to see what your schema has looked like in the past. You just look at your version control system. Again, simplified migration. They're using GridFS for client images, so they're storing the images right inside the database, not having any trouble with that. They found that when you're kind of crawling APIs or storing a lot of data from various web services, one of the things that you're not necessarily going to know all the time is the structure of your data. And so they found that MongoDB, being schemaless, is able to accommodate that very easily. So if there's a change in the API, they don't have to restructure their database. They can easily grab that information. They can use upsearch to their advantage here. If documents already exist in the database, it's fine. We don't have to check for that. We can do an upsearch. So we can do a create or update, and we don't have to think about it. Another idea, and this just comes back to the idea of the simplification that the document model gives us as application developers, the idea of modeling associations. There are a couple ways of modeling associations in MongoDB, right? One way is that we can, the basic way, and if our associations are sufficiently basic, we can embed those associations directly inside of our document. And like you've seen in the comments document before, we have the comments embedded directly inside of our blog post object. Sometimes realistically, sometimes we need to break that out into a separate collection, and that's also possible. And one of the tricks when you're starting to learn how to use MongoDB and model your data in MongoDB is deciding whether you're going to embed your data, deciding whether you're going to embed your data inside of a document or break it out into a separate collection. I really think, I just kind of want to reiterate why I think this particular data modeling is so valuable, one of the things that I was working on prior to coming to 10gen again was this e-commerce platform. And one of the aspects of dealing with e-commerce is dealing with product management. And you know that when you're dealing with product management, you need to give your administrators, the people who are administrating the e-commerce site, the ability to customize products. And that can be very difficult in a relational database if you don't want to have to actually go in and make changes to the schema as they need changes to that. So what you typically end up doing is creating a lot of tables for each specific type of data that could possibly exist. And you end up having about 18 different tables required in order to model what should be a single concept, a product. And I think that one of the things that I've been doing on this e-commerce framework is trying to remodel that data in such a way that it fits into a single document. If it's a single conceptual idea, and a product is that, then shouldn't I be able to model it as a single concept in my database? And if I have a database that's able to perform powerful queries for me, such as MongoDB, then this document-oriented modeling, document-oriented thinking really starts to make sense. Deployment is pretty basic. They don't get a lot of traffic. They're using EC2, a 64-bit server. One of the kind of side notes about MongoDB, because it uses the memory mapped files, it generally is better to have a 64-bit machine so that you can address a lot more memory. It makes MongoDB quite a bit more performant. They're simply using a single master and slave and taking snapshots. And they've also experimented for smaller apps with Heroku, which is, you heard before, a platform for deploying Ruby apps, and MongoHQ, which is a service for hosting Mongo databases. And the guys from MongoHQ are actually here somewhere. I haven't met them yet, but you can probably talk to them if you're interested. Final example is SourceForge.net. SourceForge, back in June, redid all their project pages, all their front pages, and used MongoDB to do it. So the idea was that you could go to a front page, you could go to a project page, you could go to a download page, and you could make a single query to the database and have all the information you needed to display that page. So all the information that you see, for example, on a SourceForge front page, all of the reviews, all of the tags, all of the description, the files in that project, all of that is in a single, fairly large MongoDB document. So their architecture is set up with a master server and then 5 to 6 read-only slaves. Obviously, several web servers, some of which are simply just reading data. They aren't necessarily a write-intensive application. So, but they're scaling for reads and reliability. And one of the interesting things I learned actually a couple interesting anecdotes from Mark Ram, who is one of the leads on this project. Based on their load testing, they discovered that with this current setup, they could handle 10 times their current traffic, no problem, and that they could easily scale out horizontally, that is, adding extra slaves to 100 times their current traffic levels. Another interesting thing he had to share with me was that early on, when they were building out their document model for the project pages, they were including all the release notes inside the document model. And so the documents, I told you before, an individual document in MongoDB can be up to 4 megabytes. And a lot of the documents were actually approaching 4 megabytes in size, and they were finding that there were certain bottlenecks in bringing all that data from the database. And when they actually got down to analyze the problem, they found out that they were saturating their gigabit Ethernet connection to the database server. And when they added a second gigabit Ethernet connection, they were still saturating that line of throughput to the server. So actually, MongoDB wasn't even the bottleneck for them. It was actually their connection to the database itself. So they found that MongoDB for them was extremely performant. In this case, we're talking about the Python driver, TurboGears application. And like I said, very scalable, especially for this kind of read-heavy site. So to get back to kind of summarize everything that I've said today, coming at this from an application developer's perspective, we'd all talk about the optimizations that NoSQL databases give us, but it's really worth thinking about the, mental optimization that it gives you in terms of your development time, in terms of the way you think about your data. I think that the document model combined with a powerful query language gives you those abilities. The binary storage is an added plus. Efficient binary storage, that's indexable, I think is valuable. There are obviously scalability options for MongoDB. Another thing, and like this is obviously the most important thing here to think about when talking about all these NoSQL solutions, that everybody's cases are completely individual, and you have to try out the database under your conditions to see if it works for you. The cool thing about MongoDB is that it's very easy to install. We have precompiled binaries for most systems. Anyone here could download it right now, fire up the JavaScript shell, and start playing with it. We have very good documentation, multi-language support for our drivers. All the major drivers are supported there. An active user group. If you go onto IRC, or if you go onto our Google Groups account, you can usually get your questions answered in a very, very short time. So thank you very much for the opportunity to speak, and I'll take any questions you may have.
I just had a quick question. You were talking about taking advantage of this schema-less storage of documents. Let's say you're doing some aggregation from disparate type of sites, different type of data. How would that affect querying into it later if you want to search and they don't share some common schema? What are the implications?
Well, I mean, I think that the question is if your documents have schemas that vary, how does that affect querying? Is that your question?
Yeah, or wouldn't people generally do it?
Well, I mean, I think that ideally, like, your application code is going to enforce a certain level of consistency with the schema of your documents. So if your documents do happen to be inconsistent across a single collection, then if you're going to query for a key, for example, that doesn't exist across those documents aren't going to show up in your query results. Does that answer your question?
Yeah, but it sort of fails gracefully. It goes back.
You get the documents that are relevant to the query that you made in return for the query. Yeah.
So just to add on to that, does it make sense to move them into separate collections in general?
To move what into separate collections?
Documents with different sort of schema models, if you will.
Well, I mean, I guess it depends on how different the schema. I mean, the idea of a collection is that all the documents in collection should represent something equivalent to an object, like you would have in an object-oriented programming language. So hopefully the schemas are close enough. Now, if you need to represent, like, for example, say you are modeling products, and you need to represent like a few fairly unimportant but important attributes of that product, right? Some of those products might have those attributes, some of those products might not. That's probably okay for a single collection if they only vary in a minor way. So as long as, like, in general, you can contain the idea of a single object inside your collection of documents, I think you're okay.
So I'm kind of a database old-timer. So my question is related to what happened in the early 90s regarding object databases and relational databases. There was a big war, and the relational won, basically. My question related to MongoDB is the query language and processing that you talk about appears very similar to some of the things I remember from a long time ago. But I think you are tackling it in a fairly interesting way. So what do you think? Can you talk about if relational databases can kind of do something here to co-opt what you're doing, like they did before, or is that not possible anymore?
Well, I mean, MongoDB is not, I mean, there are certain cases for a relational database where you want to use a relational database and not a database like MongoDB. Specifically, if you need a complicated transaction model, and if you need hard durability and consistency, then you probably should use a relational database, or maybe just use a relational database for those parts of your application that demand that. But the thing that we've noticed, I think, and the developers of MongoDB have noticed, is that a lot of people are representing data, especially if you can think about it, the kind of data that you see on the web, which is not necessarily the kind of data that needs to be in a transactionally safe environment, right? It's data that's a little bit more amorphous, that's a little bit more lower value. A lot of that data can be represented more easily in a document-style database than it can in a relational database. In other words, to achieve the ends that a relational database needs, you need to model your data in unintuitive ways inside of a relational database. So the question is, do I need the powers that I'm given for having modeled my data in that way? If I need those powers that the relational database gives me for having modeled my data in a way that is less intuitive, well then so be it. I'm going to have to model it that way. But if I don't need those, then it might be a good idea to check out MongoDB or another document-style database so that I can model my data more simply. Yeah?
Hi. So I have a question about the dynamic querying within MongoDB.
Sure.
And specifically, how does it scale with larger data sets? Would you need, indexes like relational database? And what kind of performance or
Well, okay, so MongoDB, so for each given collection, so assuming a collection stores related types of documents, you're able to define up to 20 or up to 40 indexes on that collection. And your indexes can be simple indexes, so just indexes on a single key, or you can also do multi-indexes. You can also index on the embedded parts of those documents. So there's really a lot of places you can go with the indexing. Now the indexing is actually very similar to a relational database indexing. So we use B trees for indexing. So I would suspect that the performance is about the same. So if you're smart about the way you model your data and you're smart about your indexes, you can get good performance. The other performance gain that you get, apart from talking about memory mapped files, the other performance gain that you get is simply the fact that you have your data in one place, you have your object in one place. You don't need to go all over the database to get it. You can pull it out in a single read, and you're done. Thank you very much.